Solving this kind of question, we have 3 steps. So step 1, we solve the associated homogeneous one. The associated homogeneous differential equation for this question is just y double prime minus y prime plus a quarter y equals to 0. And to solve this, instead we're solving the auxiliary equation. Just replace all the y double prime by m square, or the y prime by n, or the y by 1. And this is actually n minus a half square equals to 0. This gives us m equals to a half. What does it mean? We have 2 repeated roots. If you have 2 repeated roots, then based on the formula, you can construct your y1, y2 in a way like y1 equals to e raised to power mx, and here your m equals to a half, so it's e x over 2. And then your y2 equals to an extra x in front of your exponential, and that is x e to x over 2. Okay, and then your complementary solution is just c1y1 plus c2y2. That is c1 e to x over 2 plus c2x e to x over 2. Okay, then we finish the first step. We obtain our complementary solution together with your y1, y2, the basic solutions. And then step 2, we need to find a particular solution yp. So here you see, we are working on the differential equation with constant coefficients. Also, the right-hand side is a constant function plus an exponential, which means it's a good function. So we can apply the method of undetermined coefficients. So if you want to apply this method, the first thing you need to do is using the form rule to make a guess on the expression of your yp. Here you can see our gx, the right-hand side, is the summation between a constant function and an exponential one. So our yp should also formed by the summation of the expression of a constant function plus the expression of the exponential function. And for constant function, the expression from the table you can see it's nothing but the arbitrary constant a. And then for the exponential part, it's just the multiplication between arbitrary constant and the exponential part itself. So it's b times e to x over 2. After that, we need to use the multiplication rule to check if there's any duplicated terms. You can see here, the first term in yp is nothing but a constant, and our y1, y2 are not constants, so the first term is good. Then the second term, the main part is exponential x over 2, and you see it has duplicated with your y1. That means we need to multiply x raised to power n to the second term, because the first term, the constant part, has no duplicated terms, so we do not need to do anything on it. We just multiply x raised to power n on the second term. And next, if we simply take m equals to 1, then it becomes bx e to x over 2, which is duplicated with your y2 again. So m equals to 1 is not enough. That means the smallest n will be 2. And that gives us our yp must be in the form a plus b x squared e x over 2. Okay, then we need to figure out the undetermined coefficients a and b. So to find this, we need to know not only just the expression for our yp, we also need to find the expression for our yp prime. So we take derivative on yp. Constant part disappeared. What left here is b. Then the multiplication rule, 2x e x over 2 plus x over 2, x squared over 2e x over 2. So this is multiplication rule. You just be careful about the derivatives. And for yp, so we do it again. So it's just 2e x over 2 plus, okay, if you take derivative on e2 x over 2, the chain rule will cancel out the 2 in front of x. So it's e x over 2 plus, okay, so this part, x e x over 2, then plus next part, x squared over 4 e2 x over 2. Okay, and then maybe you can combine the similar terms together, will give you 2x e2 x over 2 plus x squared over 4 e2 x over 2. Okay, after you figure out your yp prime and yp double prime, next thing you need to do is to determine the coefficient in front of each term. So you see the coefficient in front of y double prime is 1, in front of y prime is -1, in front of your y is a quarter. So in front of your yp, you just write 1 over 4 times it. For yp prime, it's just -1 times it. For yp double prime, it's just 1 times it. Okay? And next, we need to compare the coefficient on the right-hand side and left-hand side. On our right-hand side, we only have two terms, a constant term and an exponential term. So here, we first need to find the coefficients of constant term on left-hand side, and then compare it with the constant term on the right-hand side. You can see on the left-hand side, we have a lot of other terms, but only in your yp, you have a constant term. And the coefficient in front of this constant term is actually 1 over 4, because you have this, times a itself. And then this part should equals to the constant on your right-hand side, which is 3. So this gives us a equals to 12. And next, another term on the right-hand side is the exponential. So you have to find the coefficients of the exponential. And this is specific exponential. It's just e2 x over 2 on the left-hand side. Only this term. And you can see in your yp, we don't have such term. This part is not the same term as e2 x over 2 because it has x squared in front of that. So we don't care about it. For yp prime, this part is not. This part is also not, so we don't care about it. In your yp double prime, okay, this is what we care about. This is not. This is not. This is not. So this is what we care about. And what is the coefficient of this part? You can see first, you have a 2 in front of x over 2. Then outside of the blanket, you have a b. And then outside of the yp double prime, you have a 1. So it's 1 times b times 2 e2 x over 2 should equals to the right-hand side term, e2 x over 2. This gives us b should equals to a half. Okay, now you figure out your a equals to 12, your b equals to a half. Then the particular solution yp should be a plus b x squared e2 x over 2, which should equals to 12 plus a half x squared e2 x over 2. Now we finished step 2. And then the last step, so step 3. General solution. So in our step 2, we successfully figure out our yp equals to 12 plus a half x squared e2 x over 2. And in our step 1, we successfully find the complementary solution. So the general solution is nothing but yc plus yp, which is c1 e raised to the power x over 2 plus c2 x e2 x over 2 plus 12 plus 1 over 2 x squared e2 x over 2. So this is how to figure out the general solution for the first question. Now for section 4.6, number 18, we again need to solve the non-homogeneous one. So step one, still the same thing, solving the associated homogeneous one. And the associated homogeneous one here is 4y double prime minus 4y prime plus y equals to 0. And we solve this by auxiliary equation, replacing or at y double prime by m squared, or the y prime by m, or the y by 1. This gives us 4m squared minus 4m plus 1 equals to 0. And actually the left-hand side is nothing but 2m minus 1 squared equals to 0. And that gives us m equals to a half. So again, two repeated roots. If you have two repeated roots, then your y1 should equals to e raised to the power mx, which is e to x over 2. Then your y2 should be x e to mx, which is x e to x over 2 here. Then your complementary solution is nothing but c1y1 plus c2y2. It's a c1 e x over 2 plus c2 x e to x over 2. And then after we finish step 1, step 2, we need to find a particular solution, yp. But here you can see on our right-hand side, it's not a good function because we don't have square root as a good function. So we cannot apply. Undetermined coefficients. I just write UC for short, undetermined coefficients. So we have no choice but to use variation of parameters. So to use variation of parameters, the first step, we have to make sure we're in the standard form. But currently not, because we have a 4 in front of your y double prime. So we divided by 4 on both sides. So this gives us y double prime minus y prime plus 1 over 4y equals to exponential x over 2 square root 1 minus x squared over 4. And next, we can find the Wronski wy1, y2. So what is the Wronski? What is y1, y2? We have finished finding y1, y2 in step 1, which is just our two basic solutions. It's exponential x over 2, x exponential x over 2. Then take derivative on each term. This gives you a half e x over 2. This gives you e x over 2 plus x over 2 e x over 2. Then to find the determinant, you use cross production. So this gives us e2x plus x over 2 e2x, then minus x over 2 e2x. So this is clear. It's nothing but e2x. Then, after we finding the Wronski, we use the formula to find u1 prime, u2 prime. We know u1 prime equals to negative y2 fx divided by the Wronski. And our y2 here is actually x times e to the x over 2. And our our fx here is the right-hand side of the standard form. It is e x over 2 multiplied by 1 minus x squared divided by 4. And then the whole thing is divided by the Wronski, which is e to the x. So you can see exponential part will be canceled. What left here is negative a quarter x 1 minus x squared. And again, u2 prime. By the formula we know it is y1 fx over the Wronski. And our y1 here is simply just exponential x over 2 times e2x over 2 square root 1 minus x squared over 4 exponential e to the x. And then e to the x will be canceled, so it's just 1 over 4 square root 1 minus x squared. Then, okay. Then, after you find your u1 prime, u2 prime, the u1, u2 is nothing but the antiderivative u1 prime dx equals to the derivative negative 1 over 4 x 1 minus x2 dx. And the u2 just equals to integral u2 prime dx, which equals to derivative quarter square root 1 minus x squared dx. Then your particular solution is just u1 y1 plus u2 y2. Okay? After you find that, then your last step, so step 3, general solution. Your y is nothing but yc plus yp. Okay?